Welcome back, guys. Last video we introduced pandas. This video will talk about two core data structures provided by pandas, series and data frames. These two core data structures are used every single day when you are dealing with pandas. Let's create a new notebook and explore them, create them and find out how we can use them like a pro. This is 02. I'll call it as a series and a data frame. Let's start with the series first. Let's understand what is a series. A series is a one-dimensional array. Simply put, it's like collection of values. Let's start with how do we create a series. So I can say create a series and see what are the different options available here and how we can create them by using different options. Let's start with first importing pandas. Before we do that, let's say import pandas as PD, and because I'm going to need numpy later, I'm going to import numpy as well. Now let us see how we can create a series. So first let's create a series from a list. Simply put, let's say I'm going to have a fruits data, which is going to be a simple list of fruits. I'm going to create a series out of them by saying this is going to be, say for example, apple, let's say banana, let's say orange, and let's say mango. Okay, so this is like a series. Let us see how does it look like. Maybe I can say this is a fruit series, and I'll put it on a second line by saying this is going to be fruits. So as you can see here, I'm getting the series. The series looks like this. On the left hand side you see 0, 1, 2, 3. These are index values. And on the right hand side, apple, banana, orange and mango, these are the actual values that we are kind of storing in that series. Simply put, all of these are string values, which means these values are of type objects. In series, if you are storing strings, it is considered as an object type value. If you want to find out what exactly it is, you can also put what is the type of it. So I can say type of fruits is going to be equals to, we can use a function called as a type and then pass fruits here. So this will tell me the collection that am I creating right now is of type pandas.core.series.series. So essentially this is a series. Simply put, we are kind of having the list of values converted into a series. Now in this case, we saw the index positions were created automatically starting from 0 to the max value -1, like length -1. Now I want to create a series with my custom index. So I can say series with custom index. Let's see the same fruits data or same fruits collection. I want to create it one more time, but this time I want to create with my index positions. Simply put, this is going to be the index position this is going to be the values: apple, again banana, the orange and the last one here is the mango. This time I'll pass an index position by creating or by passing it as an index values. I'll start with A for apple, B for banana, O for orange and M for mangoes. Now let us see how does this look like. So if you look at the fruits now, you will notice instead of having the index position starting from 0 to 3 like in the previous case, it has taken A, B, O and M as the index positions. Simply put, if I want to find out the values of a previous fruit series, like if I go for fruits of a 0, you will see fruits of 0 is nothing but an apple. But here fruits of 0 is not going to work. Instead we have to say fruits of A, and this will give me an apple. So essentially when you are going for a series with auto-generated index positions, we have to use index position in integer values or let's say numbers, while if I are creating a series with custom index, the custom values that you are going to provide here will be the positions we have to pass when you want to retrieve the values from them. Simply put, again, this is the collection of type series which will expect you to pass the index positions which exist in your index collection here. Now I can also create a series by using numpy array as well. Let's say this is my array. I can say np.array and I can pass the values, say 10, 20, 30, 40 and 50, and I can create a series out of it. Maybe I can say pd.series, and I can pass an array which I can also print here and confirm that am I getting an array or not, or series or not. And I can see that it's like again 0 to 4 because I did not provide this index positions, it auto generated it, and I can see all the values are again getting stored with the index positions from 0 to 4. I can also create a series with a dictionary as well. So let us say this is an example of a series using numpy array, and I can also create a series using, let's say, a dictionary. So I can also create by saying data, which is like maybe I can say A as value 10, B as value 20, C as value 30, and I can create a series out of it by saying series pd.series, and I can provide the data here, and let's print the series again. And notice it again, those keys of the dictionaries are taken as index positions here. So this is the way you can create a series by using multiple different options. We can pass a simple list, we can pass list along with your custom index positions, we can pass numpy array, or we can also pass a dictionary when you want to create a series. Now let us find out all the attributes the series is going to have. So let us say series attributes. Okay, so let us create a series again very quick. Let's say s is going to be equals to pd.series, and I want to pass the values 10, 20, 30, 40, 50 and 60, or maybe I can say 70, 80, 90 and 100. Okay, so this is a very simple series of values. Simply put, we are passing a list of values to create a series. Now let us find out the attributes here, starting with let's start with values. What kind of values am I having here? So it's like s.values will give me the list of values, and naturally these values we passed here in the series will get them back. So this is the values that we are storing. Along with the values, I want to also see the index positions. So index is going to be equals to index, we can pass here, and I can see the index is giving me the range of index starting from 0 to 10 with the step 1. I can also get it converted into a list, so we can find out all the index positions which are stored here starting from 0 to 9. I also want to print out what is the data type of it. So data type of the values which are storing in the series is like s.dtype, which means what kind of values am I storing in the series. Naturally, if the values are 10 to 100, all of them are integer 64 values. Okay, let's try getting the name of it. So maybe I can say what is the name of the series. So in this case, name of the series we have not provided. That's the reason why am I not getting anything right now. And finally, if I want to find out how many values are there, we can say size of a series, which is like the number of values that you are having, or a length of it. It's going to be like s.size, and I can see there are 10 values inside it. Now we know something about series. Let us start creating data frame. Let's create a data frame now. I'll put a data frame here, and let us start creating one. So I can say create data frame. So like series, data frame can be created by using multiple different V's. So let's start with data frame using a dictionary. So I can say data frame using dictionary. So let us say this is df, which is going to be equals to pd.dataframe, and I can pass a dictionary, like for example the name, like what we did last time in the previous video, Alice, Bob and Charlie. The age, let's say 25, 30 and 35, and the salary, let's go for 50,000 or 60,000 or 55,000. The same data set that we were using earlier. Print df, and this shows me a tabular data structure. Name, age and salary are the columns, and this and this, there are 3 rows available there. Now I can also create a data frame from list of dictionaries. So I can also go for data frame using list of dictionaries. That was a single dictionary we created. Now we are going for multiple dictionaries. This can be done by saying df is going to be equals to pd dot data frame, and inside it we can pass a list of dictionaries. Again, I can pass the name as Alice, age as 25, and the salary of 50,000. Similarly, let's put some other data. Let's say this is Bob and this is Charlie. This one here is 30 and this one here is 35. The salary here is 60 and it is 55. Okay, so let's put that data again, or that data frame again, on console and verify whether am I getting the same thing. So if you look at this one and this one, both of them exactly matching, which means you can create a data frame by using a single dictionary, or if you want, you can create a data frame by using list of dictionaries. You can also create it from a numpy array. It's not like a single dimensional array, you can go for multi-dimensional array. So we can say data frame using numpy array, maybe I can say multi-dimensional array, makes more sense, multi-dimensional array. Okay, oh, sorry, it's too big. I think it's better for us to use this as a comment, and we can say df, which is going to be equals to pd dot data frame, and here we can pass multi-dimensional array. So maybe it could be something like np dot array, and then we can pass multi-dimensional array like this, 10, 20, 30, again 40, 50 and 60, and let's put that df here. So you can see again I'm creating a tabular structure which is having 2 rows and 3 columns. So this is the way you can create data frame using multiple options. Now, like series, we want to find out what are the attributes of data frames are. So maybe I can say data frame attributes and find out what kind of attributes that we can explore from it. For this I need a data frame, so I'll pick this up and let us see what are the attributes that we can go for. Now, first thing first, I can find out how many columns are there. So I can find out by saying the columns, which are df dot columns, and you can find out there are 3 columns available. You can see the index is like name, age and salary, and you can see the dtype is object. The name of them are in string. You can also convert that to list. You can just get the list of columns here. So this is like the list of columns. If you want to find out what is the shape of it, shape is like you are going to get number of rows and columns by saying df dot shape, and you can see that there are 3 rows and 3 columns. Absolutely, this is what we already have observed last time as well. If you want to find out the columns or data types of those columns, we can find out by saying the data types, which is going to be equals to the df dot dtypes, and you can see that the first column name is having an object, second age is having number integer 64, and salary is also having number integer 64. Now we can also find out how we can get the column information from the data frame. So we can say access column from data frame. So we can say print df of name, and this will show me all the names of that of the persons, So we can find out df of name, which is like accessing a single column information here. We can also get multiple columns as well. So access multiple columns by using print again df of, let's put one more list inside it, and I can say name and age. I do not want salary, I just want only name and age, and I can find out the name and age information here. So it's like again one more way you can find out the multiple columns arranged in a particular manner. Okay, now let's go for the next operation. Like if I want to add a new column, how do we do that? So let us say adding a new column. Very simple. single column we'll add first. So we can go for df of a city. Let's go for, maybe it's a list also, so maybe I can say Alice stays in New York, maybe Bob lives in Los Angeles, and this third person, Charlie, lives in Chicago. Let's find out the df now, and we can see that one more column has been added now. So this is the way we can easily add a new column inside it. You can also create a column by computing the values with the existing data. So we can say add a new column, which is by computing its value from existing ones. So we can easily do that using the same df of, let's go for bonus. So let's go for bonus, which we can use a formula simply like df of a salary into, let's say, 10% of it. And if you go for finding out the df, you can see that one more column has been added, like the bonus of every single person based on the salary, 10% of the based on the salary. Now, like I added the column, we can also add the rows. So let's add a new one and say add or adding a rows. Now adding rows is going to be a little bit different. So for this we can say df.lock, and probably we can go for, this is the third position I want to add a a person named, let's say, maybe Alan, age maybe something like let's say 40, salary around 65,000, city again from Chicago, and salary, because it's not going to get calculated automatically, we have to pass our own, so it's like 6,500. And let us see the df now. So you can see that the new row has been added towards the end of it, that Alan's row, and I can see that right here. Very simple and very straightforward. So this is the way we can go for creating a data frame, adding a new column or adding a new row on the fly or dynamically. Now let us find out a few common operations available here. Common operations. Let's start with a simple finding out first a few rows. Let's say first let's say 2 rows. I want to find out first 2 rows. It can be done easily by saying df of head 2. This will show me only first 2 rows. You can also read as many rows as you want. This is an example of it. Similar to the reading first rows, we can also read or find the last 2 rows as well. This can be done easily by saying print df.tell, and we can pass the number of rows here. So I can see last 2 rows, this is like a first 2 rows. Very simple. We can also find out some random rows by saying find a random sample or random rows by using print again df.sample, and I want to get a random 2 records. Right now we are having very limited options. In upcoming series, when we go for reading the data from different files, you can find out this one will give you random values so that you can inspect what kind of values that you are having. This is especially required when you are performing some machine learning operations, like you want to get a sample of a data and perform some experiment on it. So that's where the sample can be used. So as you can see here, we have seen how to create a series, how to create a data frame. We have seen like common operations which we can perform on that in this particular video. Now next up, we'll start reading and writing the data by using different files. See you in the next week, guys. Thank you very much.